Welcome everyone online and offline. Thank you for joining us in our 7th lecture series on network inequalities. I am Samuel Martin Gutierrez. I am a postdoc here at the Complexity Science Hub. And today I am pleased to introduce Ekaterina Landgren, who holds a PhD in applied mathematics from Cornell University and is currently a postdoctoral researcher visiting fellow at the Cooperative Institute for Research in Environmental Science at the University of Colorado Boulder. Ekaterina uses dynamical systems models to study a wide range of phenomena, from voter turnout to planets beyond our solar system. Currently, she is investigating the social aspects of climate change, focusing on how society can move toward large-scale solutions for the climate crisis. Today's talk will delve into her research on modeling the misperception of public support for climate policy. So, Ekaterina, thank you for joining us, and the floor is yours.
Thank you so much for the introduction. I'm really happy to be here. So yeah, today we'll be talking about modeling misperception of public support for climate policy. The first thing to establish is perhaps why we would be talking about this phenomenon in the first place. This is a rare piece of good news on climate change, which is overall support for climate policy in the US is high. I'm just going to preface here, I tried to point out global phenomena as much as I could in this talk, but a lot of my data are going to be US-centric, forgive me. Depending on the issue, you get public support for climate policy that is above a supermajority threshold, so above 66% support. And depending on the issue, it might differ a little bit. For example, things that are taxes tend to be less popular than things that are not taxes. But most of these maps look like this. They look a little bit orange. There's a lot going on, but across the US, support for different climate policies is actually above 50%. However, people don't perceive it that way. So misperception levels of public support are also really high. On the left, there's a paper from 2021 that says that Americans underestimate popular climate policy support by nearly half. This is a Sparkman et al. Paper. I'm going to refer to it later because we use some of the data from that survey. And there's a recent paper from January that actually shows that this might be a global phenomenon, that all over the world, people have this misperception of public support where they think that it is lower than it actually is. And so in the US, if you look at support levels for climate policy, there's this gap. If you ask people, do you support a given policy, you're going to get answers that average between 66 and 80%. However, if you instead ask people, what % of Americans do you think support climate policy, you're going to be get these much lower estimates that are on the right here, between 37 and 43%. So that's a fairly large gap, and that is the misperception gap that we're interested in. We can also look at the map of the US. There's a lot going on. This is a figure from that Sparkman et al. Paper. But I want you to just take away that this map is mostly red, which means that all over the US, there is underestimation of public support for climate policy. There isn't a single state where people are overestimating it. And if you look at the numbers, you see that there is no state that is below 20% misperception. Some states are less populated, such as Alaska, and so you get larger error bars. But on average, you really see, I think, numbers above 20%. So that's a fairly widespread phenomenon. And so from here, one might ask, okay, well, what mechanisms could give rise to such widespread misperception? And in order to talk about this, we're going to borrow two terms from the field of social psychology, which are false consensus and pluralistic ignorance. False consensus is the tendency to assume that one's own opinions, beliefs, attributes, or behaviors are more widely shared than is actually the case. Or simply put, minority opinion holders think that they're in the majority. So if my favorite ice cream flavor is pistachio, and I think that everybody's favorite ice cream flavor is pistachio, I would be exhibiting false consensus, where I'm actually in the minority, but I think that I'm in the majority. And the counterpart phenomenon is pluralistic ignorance, which is the state of affairs in which virtually every member of a group privately disagrees with what they believe to be the prevailing attitudes of the group, or majority opinion holders think that they are in the minority. The paradigm example of pluralistic ignorance is binge drinking on college campuses, where college students would report that they think that binge drinking is the prevailing attitude on their campus, but they would say, well, but privately, I don't actually like it that much. I don't want to engage in binge drinking. And so what I want you to take away from this is that both of these phenomena lead to underestimation of majority opinion. Under false consensus, it is the minority opinion holders who are underestimating the majority proportion. And under pluralistic ignorance, it is the majority opinion holders who are estimating their own proportion. And again, for most climate policies, the majority are the supporters and the minority are the opponents. Before we dive into modeling, let's explore some of the survey data from the Sparkman et al. Paper. In the survey, people were asked to estimate the number of Americans who are worried about climate change, support carbon tax for fossil fuel companies, support siting renewable energy on public land, support transition to 100% renewable energy by 2035, or support the Green New Deal. And we can look at the distribution of these responses. So here on the x-axis is going to be the estimated support percent, and on the y-axis is going to be the number of respondents. So if somebody says, I think 100% of Americans are worried about climate change, they would be here at 100%. And if they said 0, they would be over here at 0%. And so this is what most of these histograms look like. Here we have actual mean at 66%, and everybody to the right of the actual mean is overestimating it, but everybody to the left of the actual mean is underestimating it. And so what we see is that there is the gap between the actual mean, which is 66%, and the center of mass of this distribution, which is the estimated mean that for this issue is at 45%. So that gap is how we could quantify the misperception. And another thing that shows up is that most of these distributions have this apparent bimodality. So there is a peak typically around 50% and another peak at around 20 to 30%. And so now we can compare different issues. So for example, on the left is the same one for being worried about climate change. And on the right is the support for carbon tax for fossil fuel companies. So looking at the right plot, we see that this distribution is a little bit more right skewed. There is more misperception because the estimated mean is actually here at 37%. And if we look at the peaks, both the two peaks are still there, but the 50% peak is now lower than the 20 to 30% peak. We can further break it down but into different demographic groups. So in the US, there's a two-party system. And so we have Democrats and Republicans. And we see that there is some difference in how they perceive support for carbon tax. So both parties members tend to exhibit widespread misperception. So here we have the difference between the estimated mean and the actual mean, but it is larger for Republicans, for whom the estimate is below 40%. And if we look at this distribution, it's even more right skewed. And if you were looking at this without any context, you wouldn't necessarily even say that this is a peak, but it's helpful for us to look at this 50% structure and see that this peak is way lower than the 20 to 30% peak. Now, the next thing, the next way to break it down is a little bit surprising, which is Democrats who watch Fox News, which is a conservative news outlet, at least once a week, tend to exhibit the same amount of misperception as Republicans. So this is our first hint at the fact that media habits and media consumption habits are going to have something to do with misperception of public support for climate policy. So this distribution is even more right skewed, and the 50% peak is even lower for this subpopulation. So now we can look at the correlation between media consumption and underestimation. In the survey, people were asked about their media consumption habits. So here we can look at the correlation between how much they underestimate public support for climate policy and what media they consume. So here on the horizontal axis are news outlets arranged from left to right on the political spectrum, and on the vertical axis are our 5 issues that people were surveyed about. And if we look at the correlation coefficients, we see 3 things that I want to point out. I think the first really stark thing is that here on the right, there is positive correlation between tuning into really conservative news outlets and having underestimation of public support for climate policy. The next thing is that the effects are somewhat stronger for the top row, worried about climate change, and the bottom row, which is the Green New Deal. That is not particularly surprising because these are issues that have more prominence in the public discourse compared to something like citing renewable energy on public land. And the third thing that I want to point out is that if we look at the top row and we move from right to left, we go from positive correlation to negative correlation. But then if we go sufficiently far enough to the left, we move into positive correlation realm again, which is somewhat interesting. So there is more underestimation of being worried about climate change for people who tune into liberal outlets that are to the left of cable news like CNN and MSNBC, which is sort of interesting. So from here, we can formulate some research questions. I would like to know if widespread underestimation of public support can be explained using social network effects. What features of a network model could replicate this behavior? And what explains the apparent bimodality of perception distributions? And finally, to what degree does media consumption affect misperception of public opinion? So now we can dive into modeling. This is going to be a conceptual model to explore some potential mechanisms that this misperception could arise. So think about an abstract social network model. Normally, in this kind of context, we might be worried about underrepresentation of minority groups, for example, gender minorities or racial minorities. And I think that it's kind of interesting that the climate opinion representation really flips this on its head, where the concern is overrepresentation of minority opinion. So it's a lot of the same mechanisms, but it's kind of an opposite problem. And in fact, this problem has a name in the climate opinion literature, which is false balance. False balance typically refers to the disproportionate representation of minority opinion. And it was very prominent in the public discourse about 20 years ago, when every time a climate scientist was on the news media would also have a climate skeptic on the news, so that it would be represented in a balanced way in terms of disagreement, but not in a way that was representative of the scientific consensus. So we're going to look at a social network where the nodes are going to represent individual people, and the edges are going to represent that those people know each other's opinion about climate policy. And we're interpreting it quite broadly. So we can think of high degree nodes as somewhere on the spectrum between a media outlet and an individual person, especially because on a lot of social networks, it's really hard to draw a strict line between a person with a large platform or an influencer and an actual media outlet. And so looking at this, we can ask each agent in our network to make an estimate. So this person is looking at their nearest neighbors and is estimating the majority percent to be 60. And we can ask every agent on the network to do the same. And the way I've constructed this particular example, we don't really get any misperception yet. But if you think about network structures, you know where this is going. By just swapping the positions of two agents on the network, we can actually change the outcome dramatically. And so now, by just swapping the position of two agents, we've entered the realm of misperception, where the average estimate is lower than the actual majority proportion. And so from here, what we want to simulate a social network with a majority-minority split in a way that is systematic and lets us get at the mechanisms. And so the classical way to simulate a social network would be to use the Barabasi-Albert approach, but we actually use the Karimi et al. Approach, where there is a heavy tail degree distribution, but also a majority-minority split. And so perhaps the people in the seminar are more familiar with this, but I'm going to go through this just in case. So here we have the standard way to grow the Barabasi-Albert network is to start with some number of nodes and then to grow that network, where at each time step a new node is added and connected to m existing nodes. And the way that the connections are chosen depends on the degree of the existing nodes. So if I show up to a party and there is a lively conversation going on, I'm more likely to join that conversation under preferential attachment than I am to seek out a lonely person standing by themselves in the corner. However, it is really useful for us to look at the minority and majority split. And so here we follow the Karimi et al. Framework, where the nodes are assigned minority or majority property according to a predetermined fraction, which again is really useful for us in this climate context because we know what the split is. And we're going to start with some number of nodes, and then we're going to add a new node at every time step. But the connections are chosen not just based on preferential attachment, but also on homophily H. So if I show up to a party and there is a lively conversation, but it's about how much people hate pistachio ice cream, maybe I'm going to go and seek out somebody else. And so here the connections are formed depending on homophily. And so we're going to assume homophily to be a constant, where for in-group connections, it is H, and for out-group connections, it is 1 minus H. So that will let us explore these networks in a systematic way. And so we can generate networks ranging from maximally homophilic on the right, where we have two components of the network, to maximally heterophilic on the left, where we have one component and where minority nodes tend to have a larger degree fraction. So from here, we can now connect it to our notions of pluralistic ignorance and false consensus. So under heterophily, when H is 0, we get pluralistic ignorance because all of the majority nodes only know minority nodes. So they think that they are in the minority, hence pluralistic ignorance. And we also have widespread misperception. So the gap between estimated mean and actual mean is large. But we don't have false consensus because the minority nodes also think that they're in the minority. And then under a completely homophilic network, we have false consensus because the minority nodes think that they're in the majority. But we don't have pluralistic ignorance because the majority nodes also think that they're in the majority. And we also don't get this widespread misperception. So under this homophily framework, minority and majority have complementary biases. So we don't actually get coexistence of pluralistic ignorance and false consensus. So we don't get it in heterophilic networks. We don't get it in homophilic networks. And if we pick a network somewhere in the middle, we also don't get it because there isn't any difference between being a majority node and a minority node on this kind of network. And also, we don't have widespread misperception anywhere except the heterophilic networks. So homophily effects are not sufficient to get the kind of phenomenon that we want to model. So where do we go from here? Well, we can make several observations. First, we can say, okay, false consensus is achieved through high homophily. So minority nodes need to have enough minority node connections to get false consensus. And pluralistic ignorance is achieved through centrality of minority nodes, where the majority nodes need to be connected to enough minority nodes to get pluralistic ignorance. And so looking at this, we might say, well, we probably don't live in a heterophilic network where we connect to those that disagree with us on the issues of climate, but we might live in a world where minority opinions on climate specifically are overrepresented among central nodes. So that is the thing that we explore next. What happens when minority nodes are overrepresented among central nodes? Or in other words, what if we have false balance among our central nodes? And so to do this, we propose a really ad hoc mechanism, which is, again, the simplest thing that you can do in a conceptual model, where we're going to just swap highest degree majority node and lowest degree minority node iteratively. So we're going to artificially promote minority nodes into positions of centrality. I call it the Prince and Pauper strategy. And so this is a different kind of plot. Here on the horizontal axis, we're going to have the number of swaps. So the number of minority nodes that we're promoting into positions of high degree. And on the y-axis, we're going to have the mean opinion estimate. And the actual percentage is here at 66% again. And then the different grayscales are different values of homophily, going from really pale for heterophilic networks to really dark for homophilic networks. And so when we look at this, it's not surprising, right? As you start giving minority nodes a larger fraction of the degree share, you are going to see that estimate go down. And eventually there is no more benefit to promoting minority nodes, so it asymptotes out. That's not surprising. But something that's kind of interesting is that it doesn't take that long to get into the empirical estimate range of that 37 to 43%, even for really homophilic networks. So this is a way to start with a homophilic network and then to impose this kind of intervention to get us into the empirical estimate range of misperception. And so we can also look at the kind of distributions that we've made for the survey and for the networks with just homophily, where we can look at the estimated support percent. So here's a network that almost does what we want, but not quite. So here we have widespread misperception. We have the 25% peak, even though it's closer to 40. So instead of being between 20 and 30, it's between 30 and 40%. We have the 50% peak, but we also have these spurious other peaks at 0 and 100%. And so why do they show up? Well, it's a matter of network density. So here M was 2, so every node during the growth phase of the network was making just 2 other connections, which led to these extreme positions of 0 and 100. But as we increase network density, we actually don't have these spurious peaks, and instead we have everything we want. We have our apparent bimodality, we have widespread misperception, and we don't have any other peaks. So qualitatively, we're capturing a lot of the things that we set out to capture. So if we start out with a homophilic network and then we make a few swaps to promote the minority nodes into positions of centrality, we can capture some of the qualitative behavior that we're interested in capturing. And if we compare it to the data, we can see the qualitative similarity. And also, unlike the survey responses, we can break it down into majority nodes and minority nodes. So that lets us confirm that there is indeed both pluralistic ignorance and false consensus. So using our very ad hoc intervention, we can achieve the coexistence of pluralistic ignorance and false consensus, because both majority nodes and minority nodes are underestimating the actual share of majority opinion. So to recap, homophily effects by themselves are not sufficient to capture the coexistence of pluralistic ignorance and false consensus. So you get one or the other, but you don't get both. And if you add the oversampling of minority opinion among central nodes, then you actually get the coexistence of these things. You get pluralistic ignorance and false consensus, which is what we observe empirically in the climate opinion data. And so the next part of this project is investigating whether or not we live in a world where minority opinion is overrepresented among best connected nodes. So it seems like if we make this assumption, we do get qualitative match in between our model and the data. And it seems a fairly reasonable assumption, but we wanted to dig deeper into it and see if that actually turns out to be the case. And so the next step in this project is learning more about how media covers climate policy. Some aspects of media coverage are really well studied. Here is a paper from the Boykov group, which is also based at CU Boulder. And in 2004, they documented that US press coverage of global warming has continued to a divergence between popular discourse and scientific discourse. However, and this is the second piece of good news on climate change, this part has been getting better. So the same group released a paper in 2021 following up on this study, and they actually expanded it beyond the US. So the 2021 one has data from several countries, and it's both print and television. And they found that scientifically accurate coverage of climate change is actually improving over time. So the Boykov group runs what is called the Media and Climate Change Observatory here on campus. And they track the number of mentions of the terms climate change or global warming in different media outlets. So here I put the European newspaper coverage, and it's really cool because that data set goes back 20 years. And so you can really look at different trends. And the dotted line is all newspapers combined, but you can look comparatively sort of which newspapers are covering climate change more. And so here is the plot for US television coverage, where you can also see trends. For example, in June of 2020, the mentions of climate change went to 0 because every single media outlet was covering Black Lives Matter protests, and they weren't really talking about climate change. And if we look at this box that contains the number of mentions for March, we see that CNN talks about climate change the most, and Fox News is a second by the number of mentions, which when I first saw this was a little bit surprising. However, there hasn't really been inquiry into the coverage of climate policy specifically. So much of the research is focused on the coverage of climate science and climate change denialism, that there hasn't been that much about the coverage of climate policy. And so it's easy to find examples that are both pro and con climate policy. So here is an argument for from CNN, where we should be in an all-out effort to move to renewable energy and to save energy so that we don't have to use as much of it. But for not for every example, but you can also find examples that argue against climate policy. So here is a quote from Fox News where they say that Joe Biden's taking advantage to push the Green New Deal so that his donors can get paid and not people like ExxonMobil who usually donate to Republicans. And so we wanted to investigate this again in a systematic way and to look at how climate policy is covered on average. So to do this, we started with a corpus of TV news transcripts that are selected based on mentioning climate change or global warming. And for each of the transcripts, with a team of human annotators, we answered the following 3 questions. Does this segment acknowledge or deny that anthropogenic climate change is happening? Does this segment express climate concern or opposition to climate concern? And you can imagine that somebody could express climate concern without acknowledging something, or maybe they could even express it at the same time as denying anthropogenic climate change. And finally, we look at whether or not the segment supports or opposes climate policy. So these are preliminary results. Actually, as of yesterday, my team has finished annotating the whole data set, but I haven't had time to make new plots. So here we're going to look at the preliminary results, which is about halfway through the data set. So we are going to look at science of climate change, attitude toward climate concern, and attitude toward climate policy. And so for science of climate change, we're going from acknowledges to denies, and we have a little bit of a debate, even though there hasn't been any in the data set. And again, the majority opinion is going to be represented in yellow, the minority opinion is going to be represented in blue. For attitude toward climate concern, we have a lot of expressions of climate concern, more than neutral. And then we have a share of opposition. So there is more opposition to climate concern than there is explicit denial of climate science, which consistently with what other researchers have found is fairly rare now. And here we have attitude toward climate policy, where we have a lot of support, but also a lot more opposition to climate policy than we have opposition to climate concern or denial of climate change. And we also see a lot more debate about climate policy than about these other issues. But I am hiding something from you on this slide. And if you're looking at axis limits, perhaps you've already found it, which is I hid this giant bar from you, which is no mention of climate policy at all. So in the preliminary data, what we found is that 88% of transcripts that mention climate change don't talk about policy solutions at all, don't mention any policy solutions. Another thing that you might note is that we don't really have false balance. So we have more opposition to climate policy than we do to climate concern, but the ratio of these is not really corresponding to false balance. Another thing that we can do is we can look at different news media outlets. There are 7 in total, but I've selected just 4. And what I want to point out is that one of these news outlets is different from the other ones. So here for science of climate change, we have a lot of mostly even split or almost even split between acknowledgement and neutral. But here for the bottom left plot, we have mostly neutral and a lot more denial and a little bit of debate. And then if we look at attitude toward climate concern, again, the bottom left plot is different, where we have more opposition to climate concern than we have climate concern, and the largest bar is neutral. And then finally, for climate policy, we see that the outlet in the bottom left has no support for climate policy and only has opposition to climate policy. And so it again stands out. And the 3 outlets that I omitted look kind of like these 3 outlets. And so the one in the bottom left is quite different. And depending on how familiar you are with the US media landscape, you probably have already guessed this, that the bottom left outlet is in fact Fox News. So it really does cover the climate issues differently from the other outlets in our data set. Another thing that we can do is we can weigh our results by the views. So we have survey data on people's media habits, so we can estimate sort of synthetic rankings. We can estimate how many views different news outlets get and look at the news coverage of climate policy that way. We had to group things differently because of the way that people were surveyed about their media habits in the survey. And so that's why you see different colors. But the upshot is that we don't really find false balance. Even though a lot of people watch Fox News, it's not enough to overcome the overall proportion. So if we look here, the ratio between support and opposition to climate policy doesn't really rise to false balance. In this subset of the data set, it was about 3-to-1. So we don't have overrepresentation of minority opinion, which is a null result, but it was really surprising to us. And so where do we go from here? That was sort of anticlimactic. We made a hypothesis and then we kind of got a null result. it seems like we don't have overrepresentation of minority opinion about policy in the news. Well, something I'm excited about is looking at the mechanisms outlined in this paper, where they looked at the pluralistic ignorance among Republican climate change supporters. And so what they describe is this feedback loop where Republican supporters of climate policies are more likely to self-silence because they perceive their information environment to have an unrepresentative share of climate policy opponents. So at least in this survey, people were documenting that their information environment does have this unrepresentative share of opposition to climate policy support. So for takeaways, if you only remember one thing from today, let it be this. Most people underestimate public support for climate policy. This is a global phenomenon, and climate policy really is more popular than most people think it is. Next, echo chambers alone do not explain widespread misperception. So homophily effects by themselves are not sufficient. It has to be something else, not just homophily. And an unrepresentative information environment can help explain this phenomenon. So it doesn't appear to be news media in this case, but it might be an unrepresentative information environment. There are three directions that I'm hoping to explore next. One, now that we have the data set that is human annotated, we want to use large language models and AI tools to annotate more transcripts. Without a human annotated training data set, the large language models didn't perform that well because there's a lot of nuance in these transcripts, and you cannot really do just plain sentiment analysis to get at the kinds of questions that we were getting at. But hopefully now that we have this corpus human annotated, I could be more successful with that. The next thing is to explore opinion on climate policy on social networks. So TV news media is just one way to investigate this. So the next step is to do this kind of analysis for real life social networks. And as I'm sure many of you know, it's been really tough now that you cannot access the Twitter data set, but we're hoping to do something with the Reddit data set and look at the structure of these kinds of networks. And finally, I want to investigate the potential self-silencing asymmetry, which is something that might be done with a kind of transparent conceptual model. So how much asymmetry between supporters and opponents of climate policy do you need in self-silencing in order to get the widespread misperception that we see in the real world? I'd like to thank my project collaborators. It's been absolutely amazing. Jeremiah has helped me a lot in terms of framing the human annotating process, and that has been invaluable. Joshua Garland has been absolutely wonderful in terms of talking through the modeling. And I would like to thank my PI, Matthew Burgess. And I am so delighted to have the annotation team of undergraduates and one master's student. When I started this project, I really thought, oh, I was saddling them with something boring and repetitive. But every time we met, they actually reported that they quite liked looking through this and kind of estimating how different news outlets approach not doing explicit denial of climate change, but still communicating opposition to it. So it's been absolutely wonderful to have them. I'll leave the takeaway slides up, and that's it. Happy to take any questions. Thank you so much.